Hello everyone, welcome to lesson 8-2, area of circles. Let's continue to answer or address the question, how do measurements help you describe real-world objects? And for our vocabulary today, we're going to look at semicircle. Let's look at this image to review lesson 8-1, where we learned about the circumference. Circumference is the distance around the circle. Circumference, circle, right? And we also learned about the radius. The radius is the distance from the middle of the circle to the rim of the circle. So this would be the radius. And the diameter is the distance across the circle. So radius times 2. Now let's look at a real-world problem to see how area of a circle comes to be in real life. So pets. Adrian bought an 8-foot leash for her dog. So from the center to the rim is 8 feet. It's an 8-foot, so that's our radius, isn't it? Adrian wants to find the distance the dog runs when it runs one circle with the leash fully extended. Should she calculate the circumference or the area? Okay, so the circumference, she wants to know the distance the dog runs when it runs one circle with the leash fully extended. The leash fully extended would be right to there. And if the dog runs one full circle, we are measuring the distance around the circle, are we not? So we really just want to know the circumference. So she should calculate the circumference right there. Okay, so let's look at question 2. Suppose she wants to find the amount of running room the dog has with the leash fully extended. Should she calculate the circumference or the area? Running room, the running room. So with the leash fully extended, the running room, how far can it run? Okay, as far out to the rim. So all of this in here is considered running room, right? So she should find the area to know how much room, all of this is considered the area, all this area in blue, to find out the running room the dog will have. So the dog can frolic anywhere within that area, because that's how far the leash will allow it. Number 3. Describe a real-world situation that would involve finding the area of a circle. When I think of a circle, I think of my breakfast table, right? My breakfast table, it's a circular table. And if I want to buy a tablecloth for it that will fit right to the rim, right to the edge, and cover it perfectly without draping over, I would want to know the area. So finding the area of my round table to get an idea of the size of the tablecloth I should buy. Please feel free to think of your own real-world situation, and we can share in class. Question 4. Describe a real-world situation that would involve finding the circumference of a circle. This is what I'm looking at right now. This is the table I'm working on, and it's a circular table, correct? If I wanted to buy this bumper for the table, let's just pretend it never had it, and I want to make the table safe for my little students, I would want to add this bumper to it. So knowing the distance around the table, the circumference, would be helpful in knowing how much of this material I need to buy, this rubber. So finding the circumference of my table so I know how much rubber bumper to buy. In order for us to find the area of a circle, we really need to be able to identify the center of the circle. So measure from every angle of the edge until you find the same measurement to the center. And that's how you'll know where you have found the center. So the distance from the center to the edge is your radius. So you must know your radius. The area of a circle equals the product, okay, with the multiplication of pi and the square of its radius. So we take the radius and we make it square. We multiply it times itself, then times pi, and that'll give us our area. As you can see here, area equals pi times radius squared. Please take the time to memorize this formula where area equals pi times radius squared. I know that after some time this will really start to make sense to you, that you need to use the radius square, because remember, area is always square, so you're only going to use the one measurement that you know, which is radius. You square it and multiply it by pi. Okay, so let's take a look at an example done for us where we have a radius of 2 inches, right? Radius of 2 inches, so 2 inches squared, 2 times 2 is 4, so that'll be 4 times pi, correct? Let's see how it's done. Area equals pi times radius squared. Replace the variables. Pi is 3.14 and our radius is 2, as we saw up here, okay? And then we have 2 squared, which means 2 times 2, the base is multiplied into itself once. We get 4, and then 4 times 3.14 is 12.56. So our area is approximately, now remember, anytime we work with pi, it's always going to be approximately, okay? Check for reasonableness. Yeah, we did. Reasonableness would be this square times 3. This square is 4, and we multiply it times 3, which is, to get an estimate, would be 12, right? You see how it did it here? 2 times 2, multiply times 7, and then 3. 3 is representing pi, is about 12. Is it close? It is. Now let's take a look at example 2, where we have a multiple of 7. And remember, whenever we're working with a circle and multiples of 7, we can use 22 over 7 as our pi. And you can see here that if 14 is our radius, right, we're multiplying 14 times 14, then times 3. Okay, that's to get our estimate, and it should be around 558. So we have area equals pi times radius squared. The pi we're going to use is 22 over 7 times 14 squared. 14 squared is 196. And then we cross-reference, right? How many 7s are here? 28 and 1 here. So then we have 22 times 28 equals approximately 616. All right. If you think you got it, please pause the video and find the area of a circle with the radius of 3.2 centimeters. Round to the nearest tenth, so the first decimal place. Now, just a quick review. Area equals pi times radius squared. Okay? Area equals 3.14 times 3.2 squared. Right? 3.2 squared, as you can see right there. Go ahead and do the computation and see what you get. Pause the video, please. Okay, I hope you paused the video. I get area is approximately 3.14 times 3.2 times 3.2 is 10.24, and then area is going to be approximately 32.1536, which is approximately, to the nearest tenth, just the first decimal place, 32.2. This is 5, so it's higher than 4, so it's going to change that to a 2. Okay, and what is our centimeters? cm. Okay, now let's apply it to a real world example. Here we have a coin, okay? It looks to be like a Virginia coin, and it's a quarter, a Virginia quarter. Find the area of the face, so off the face, everything right here, all of this, of the Virginia quarter with a diameter of 24 millimeters. Diameter, a distance across, okay, the diameter, don't confuse that with the, okay, the distance across. So we're just looking for half of that, right? Just that. So we need to cut it in half, right? Use 3.14, round to the nearest tenth. So yeah, we have to cut the diameter in half, and you can see here that that's what they do. the radius is half of the diameter. So you take the number and multiply it times a half, because whenever you multiply a number times a half, you get a half of that number, which is 12. 24 times a half is 12. So yes, our radius is 12. And we go ahead now and we have the information we need. 3.14 times 12 squared. 12 squared is 144, right? 12 squared, 12 times 12 is 144. And multiply that times 3.14, 452.16. Round to the nearest tenth. This is 5 or greater, so it'll change this up by 1, and we get decimal 2. You see, instead of decimal 16, it's decimal 2. 452.2 square millimeters. Oh, I'm so happy that they wrote the word square. I had not talked about this yet. All area is two-dimensional. It's square. The bottom of a circular swimming pool with a diameter, distance across, of 30 feet is painted blue. How many square feet are blue? So the diameter, what's half of this diameter? It's going to be our radius, and our radius is, so here's my pool, and it's the diameter is 30, right? All the way across, that's 30. We only want half of it, and half of 30 is 15. If you can't do that, just take 30 and divide it by 2, and you'll get 15. So now we have area equals pi times radius square. Area equals 15 is not a multiple of 7, so we'll use 3.14 times 15 squared. I'll continue up here, and I have area is approximately 3.14. 15 times 15 is 225, right? 225. So area is approximately 706.5 square feet squared. And there you have it. And now we come to the word semicircle. Semi means half a circle. Okay, this makes it a half a circle. Semicircle is half a circle. A semicircle is half a circle. The formula for the area of a semicircle is area equals half of the area of the circle. So whenever you have a number and you multiply it by a half, you get half of that number. Don't forget. If you wanted to, you could simply also get rid of this half here and just simply put it all over 2, which means you would divide your number by 2 at the end. So let's look at example 4. We have our formula multiplied by a half, so that we can get half the number, because it's only half the circle. You see that? Semicircle is only half the circle. So we either did multiply it by a half or divide this number by 2 without multiplying it by half. You'll get the same answer. So here we go. We replace our variable with our pi, 3.14, and our radius, remember it's radius squared, it's half of our diameter. Our diameter is 16, so we need our radius, which is only half of 16 right here, 8. Okay, 8 and 8, correct? So it's 8 squared. 8 times 8 is 64. 64 times 3.14, okay? Another way to do it is, at this point, you could use commutative property of multiplication, and you could multiply the 64 times the half, and you would get half of 64, which would give you 32. And then you can multiply the 32 times 3.14, right? When you do so, you get 100.5. So that's about your area of your semicircle, only this half. And keep in mind that your units is always square, because we're talking about area, 2-dimension, and you include your inches. Question C. Find the approximate area of a semicircle with a radius of 6 centimeters. So we will use our formula. Area equals half of our area of a circle, which is pi times radius squared. Half of pi times radius squared. Correct? If you prefer to divide instead, you could find the entire area of your circle. You see that? And then you just divide it into 2, because you're only accounting for half. So it's area equals pi times radius squared divided by 2. You only want half the circle, right? It's a semicircle, as you can see right there. So we replace the variables, and we get a half of our it's half times pi, 3.14, times 6, because 6 is our radius. You see it right there. Squared. 6 times 6 is 36. And then we carry down our pi and our half. Okay. I could go ahead and use commutative property of multiplication and multiply a half times 36 now. So I get half of 36, which is 18. I could do it like that. Or I could multiply this and then half it. You know, multiply it times a half. I'll do it the way I just said. Half times 36 is 18, okay, times pi. And now we simply multiply half of our area of circle times pi. There we go. So 18 times 3.14 is 56.52 centimeters squared, right? In centimeters, you can see right there. If you chose to do it the other way, by using this formula, you replace pi, you replace your radius, squared, you solve for this, so 36, 6 times 6 would be 36 times 3.14, and you divide that by 2, and you will get 56.52. And to conclude, here's a real-world example. On a basketball court, there's a semicircle above the free throw line that has a radius of 6 feet. Remember this, the semicircle from the free throw line at the very top of the key? Find the area of the semicircle. Use pi to round to the nearest tenth. So that's how you would do it. We're only looking for half the area, so we're going to multiply the area that we get by multiplying the radius and the pi times a half. So you solve for that, okay? And there we have it, and it's 56.5. Actually, exactly the same as the previous question. Here we have our guided practice. Please take a look at it as we will begin class with this. See you in class.